in this video I'm going to very quickly summarize friction. Now, I classified there's 4 different kinds of friction questions. This is a punism, only I use this terminology, right? Don't use this terminology and expect other people to know. If you have a box on a flat surface and a parallel force, it's pretty easy. It's boring. It's trivially easy. F equals mu n, right? You'll have remembered the song, right? The Kazoo Kid. Pharrell, he has a song about fun as well. It's pretty easy. So that means that the friction force, right, that's going to be resisting this, so if we call this P, right, the pulling force, we're going to have a friction force resisting it. The friction force is going to be equal to the normal, and the normal is going to be equal to the weight of the box, which is mass times gravity. Yeah? So as long as you know the coefficient of friction, you can determine the friction force if you know the mass of the box and the gravity of the planet that you're on. Usually we can assume that you're on Earth, so you can multiply by 10 in our HSC. At professional level, you'll work with 9.8, but they understand the exam conditions, you just multiply by 10. Now, what then that happens is we know that in this situation where we have the next one is called a bear, right? I think of a bear pushing a box, right? So you have this bear, he's either pushing or he's pulling the box, it depends which. That came from me talking about if I had a bear who's pushing this box and I did the action of either pushing or pulling the box. I have seen other people have pictures of bears, I don't know if that's a coincidence. Anyway, we call it the bear in the box. In this situation here, if we look at the sum of the vertical forces, we have weights down, which is mg, which is resisted by the weight is going down. We have the normal reaction. Now, depending on if the bear is lifting the box or pushing the box down, you'll either add or subtract. If you're lifting the box, you're making the box lighter, so you're going to minus that value. If you're pushing on the box, you're increasing the weight of the box, in which case you're going to add, right? So that's why I have plus or minus, depends on if you're increasing or decreasing the weight of the box. Now, in terms of the horizontal forces, if we had some of the horizontal forces equal 0, we have pH, and pH is resisted by friction. There, if we're looking at the exact moment where the box begins to slide, pH and FF, or the friction force, are going to be exactly equal. So we can see that F equals pH, and which is hilarious because pH makes an F sound, which is why I call this the phony friction formula. It's the friction formula, except that what we've done is we've replaced F with pH, and we've replaced N. Some of the forces vertically tell us that N is going to equal mg plus or minus PV. Now, in this case, I have given you the trigonometry values of those, and I've written that down in red. I don't like the red formula, and the reason I don't like the red formula is because 2 reasons. The first reason is because it no longer is a phony friction formula. It loses the F sound, but maybe this works for you. The second reason why I like this is because almost always the values you're going to... Okay, when I say almost always, very often bare questions in the HSC have been 30 degrees, which means that if we know this is 100%, this is going to be 50%, and this is going to be 0.866%, right? Which, if I know that this is P, I can replace 100 and write P, I can write P on 2, I don't know why we're Ping on 2, but anyway. So, I like to use that. I like to use that as my substitution because I want to skip that step. Often these questions will be one mark multiple choices, and we have to be able to answer these questions in about 1.5 minutes, right? A little bit more than 1.5 minutes. So it's important that we can simplify this down. Now the last formula is the too many guys formula. How I remember this formula is that my friend, he went on a boat, and he went to a party on a boat. There were too many guys. Then he hit his head on a sign, and then someone sneezed on him, and he was covered in mucus, right? That's the mnemonic. Now, how that works, I'm going to tell you this quickly. Now, most of my students who learn this, and my students do well on this. I look at HSC results, my students do really well on this because they have this too many guys formula. I'm the only person, I came up with this, I've never heard anyone else use this boat formula, right? But the idea is here that if you can just go in and know this formula and know how to apply this formula, you're going to be happy. Now, what is the formula? Well, if we look at our boat, what we can do is we can break down the weight of the last one. I'm not even going to talk about the last one, is if we have something on a slope and the force is not parallel to the slope. I call those BS questions because beans and sprouts or some other combination of B and S. Anyway, so if I have my boat, I have the mass of the boat, which is affected by gravity. My boat's a little bit too big. I'm going to make that a bit flatter. Right, it's affected by gravity. Now, what direction is gravity?
No.
It's always down. It's always vertical. It's always the hypotenuse. That is critically important that you remember that gravity is always down. It is always vertical. It is always the hypotenuse. Now, if I know this angle is theta, then this angle will also be theta. I'm not going to prove that. You just have to trust me on it. Now, what that means is that this value here is adjacent to it, so it's going to be mg cos theta. Now, I'm going to say that some of you already have turned off this video, or you should be turning off this video. If you're not looking for a 90 in this subject, you know what, just learn the too many guys formula. But if you ever want to deal with the BS questions, this understanding will help you. So I just want to go in a little bit more detail. But I'm saying some of you, this is where you're allowed to tune out. This one here is the mg sine theta. Okay, so that's the weight force. Now, what are our other forces? We know that there's another force here, which is the normal force, and that is always perpendicular to the surface. Now, we can look that if we set our own, normally we use vertical and horizontal as our directions, but in this case, we're going to set our own axis called x and y. And if we take some of the forces in the x-axis, some of the forces in the x-axis equals 0, what do we know? We know mg cos cos theta has to equal n. Because there's no other vertical forces on this, there's no other forces in the y direction. Sorry, this is y, some of the forces in the y direction. Whoops. Okay, in the x direction, well, we have mg sine, and that's what causes, when you have a car, your car breaks down on a hill, what causes the car to roll down the hill? That force, the force of gravity. This is a force of gravity that is causing the car to roll down. Sometimes these forces, I'm going to label them differently in a second, just to go, I'm going to repeat this. But so the car is rolling down the hill. What is stopping the car from rolling down the hill? Friction. Okay, so what are the forces that we have rolling down the hill? We have friction and we have mg sine. And those two are opposing each other. The question is, what is the force of friction in this calculation? So let's have a look. We have, so fx equals 0. We know that mg sine theta equals friction. Okay, so now what we can do is we can apply that formula with our third formula to complete the simultaneous equation, which is F equals mu n. So let's take that. We've got F equals mu n. What is our friction? Our friction is going to be equal to n, right, times mu. Okay, so what is our n? Mu times mg cos theta, right? Because we figured out n equals mg cos theta. Okay. So, what is our the total forces that we have sliding down the hill, right? We also have a cable pulling this. If we have a cable pulling this thing up, we now have a third force, right? In that situation, friction is no longer pushing up. Friction is now resisting. Friction is now being a pain, and friction is pulling back, saying, no, I don't want to go up. Because remember, friction doesn't want to move. If your car is rolling down the hill, friction is helping you to stop that car from rolling down the hill. If you want to start pulling the boat up out of the ramp, friction is now being a jerk, and friction is saying, no, I want you to stay where you are. That's what friction does, right? Friction resists movement. So in this case, we know that F equals that formula, right? Here's what we know. We know that the tension in our sum of our forces in the x direction, we now have tension. If we set this direction as positive, that's positive. We have 0 equals t, which is positive. We have minus f. And is this going down? It's also going minus mg sine theta. Okay. What we can do is we can change our signs and say t, so effectively putting this over here, that becomes minus, and all these minuses cancel out. Are we okay with that? That's an algebra thing, but that makes sense. Yeah. If we move that over here, it becomes minus, everything's minus, so it cancels out. So we have, I'm going to substitute f. We said f is this formula, but I'm going to write it differently. I'm going to write it as mg mu cos theta, and in this case we're minusing mg sine theta. Okay, the last thing I'm going to do is I'm going to take mg, I'm going to factorize Now, I've written the story a little bit differently to what we have up here, right? Here, in this case, he got sneezed on before he hit his head on the sign. But we see how we've derived that formula. Now, the last thing I'll refer to is sometimes people use a different terminology, and I'm just going to write that in here. Sometimes people don't call this mg sine theta. What they call this is they call it, if we're weight is down, so if this is weight, this would be W in the x direction, and this would be W in the y direction. Yeah? In which case we can then say T I'm going to get rid of this line here, and we're going to say, in that case, T is equal to x in the x direction, which is going down. I want to make sure that I do friction first. So friction, we said, is equal to mu times, well, it's equal to normal reaction, right? Mu times the normal reaction. We know the normal reaction is equal to Wy.
Why?
Mu times Wy minus, this changes to a plus. Sorry, when we did our algebra, and I said it was really simple algebra, we had to make both of them turn both the minuses and the pluses. And that makes sense when we look at the T is going this way, Wx and F are both resisting us. Do you see how both of them are resisting the T? Yeah. Okay. Good work, video. And Wx. So we have, what are the two forces that when we're pulling the cable, there are two forces resisting us. The friction and just the weight of the boat. We don't have the full weight of the boat, only part of the weight of the boat. Why? Because the boat is on an angle. So we have part of the weight of the boat, which is Wx, and the friction. To calculate friction, we need to know Wy, because that's N is equal to Wy. So mu N, F equals mu N, and that. Now, I go into all of this in more detail in another recording, but sometimes it's useful to have a summary, and this is where these formulas come from. Ultimately, for the third type of questions, for the bean sprout questions, then you really just have to apply these same three formulas. Some of the forces in the y direction equals 0, some of the forces in the x direction equal to 0, and F equals mu N. If you do that, any question that's friction-based, you can solve. But hopefully that should be enough to give you an idea of the theory. I have recorded other videos already that cover half a dozen HSE questions. And we're done.
Like and subscribe.